Consider the region bounded by the curve y equals root x, the line y equals 2, and the y-axis. Determine the volume of the solid obtained by revolving this region around the y-axis. Okay. So we're used to working with the x-axis, but there's really nothing wrong with setting up a volume formula for a solid of revolution and integrating a function of y with respect to y. There's no harm in that at all. But it does usually require a little bit of extra work or thought because, as we can see in this question, the way we tend to be given functions is y equals something in x. But if you're revolving around the y-axis, you really want sort of x as a function of y. So that sometimes we have to do a little bit of a rewrite. Okay. If it helps, sketching the curve can always be sort of nice. So y equals root x. Looks a little something like this. Sort of a half a parabola on its side. What else did we have? Y equals 2, I believe. Yeah, y equals 2. So we'll say that sort of hits here. This one keeps going. And then the y-axis. So we want this area in here. Now, if we're going to set up a volume integral, we need to figure out where along our axis, in this case the y-axis, we're integrating. So we need to go from 0 up to, well, luckily it was y equals 2, so we know exactly how we're going to set this up. We go from 0 to 2. Same as if we were working along the x-axis and rotating along the x-axis. And what can we do here? Well, I can see, we can even try and imagine a little bit what's going to happen if we rotate around the y-axis. The x value is what's going to give us our radius, and maybe we should use the red. Okay, so what we should do, and it's coming from this curve here, the y equals root x function, so what we should do is we should rewrite that in order to talk about x, because x is going to be the radius for our circles. Okay, so we'll just square both sides. X is y squared. Okay. So we need pi times the radius of these circles squared. That's going to be pi times x squared, which should be our function y squared, all squared. Okay? It takes a little getting used to integrating and rotating around the axis that we're not usually comfortable with, okay, the y-axis here. But as long as we take the time to remember what things should look like, what we actually need to make these formulas work, and where these formulas came from in the first place, it's not so bad. So we'll bring the pi out. Y squared squared is going to be y to the 4. And from here, I mean, the fact that we've got a y doesn't even matter. We know how to integrate. Okay, so we'll do y to the 5 over 5. Evaluate that from 0 to 2. So 2 to the 5 over 5 minus 0 to the 5 over 5. That's going to be pi. The 0, everything's going to go away there. So we'll have 32 is 2 to the power 5. So 32 fifths pi. And that's our final answer. So once we actually got the setup, this wasn't a problem. Okay? It's the thinking, how does the formula work when we're integrating, or sorry, not integrating, rotating around an axis that we weren't explicitly told about. You know, in the lesson we were working with the x-axis, which quite often we do. But there's nothing wrong with applying our process to rotating around the y-axis. You just have to stop and think, what should be the radius for all these sort of cross-sectional circles that we've got? Okay, well, how far away is my curve from the axis? Well, it's the x-coordinate away. So we need to rearrange to solve for x. So we were given y equals root x, but we should rewrite it as x is y squared.